Hello everyone, I welcome you all for the lecture series videos of hydraulics and pneumatics. In the previous video, we have discussed about the flow control. Why flow control is necessary, why we have to control the velocity or the speed of the actuator. Since the flow is directly related with the speed or the velocity of the actuator, by controlling the flow rate, we can control the velocity of the actuator. So in this video, we have a detailed discussion on flow control valve. I'll introduce what is flow control valve, how the velocity can be controlled by controlling the flow rate of the cylinder, and how the flow rate of the fluid can be controlled by the mechanical configuration of the valve. So let us have a deep dive on this. So we know that the discharge coefficients of the fluids are typically used in fluid mechanics. You might have studied in the fluid mechanics. That is the foundation course in hydraulics and pneumatics. We have various formulas for the discharge coefficient uh, in order to do some mathematical calculations. So these coefficients are available in most of the technical references of the fluid mechanics books and fluid related books to cover the entire fluid mechanics. So we know that the formula used to calculate the flow rate of the fluid, that is discharge, it is denoted by the letter Q, where QA is the actual quantity of flow, is proportional with the area and coefficient of discharge and gravity head. By combining this, we have a formula QA is equal to A naught into CD into 2 into G into H, where QA is the actual quantity of flow and A naught is the cross-sectional area of the orifice and CD is the coefficient of discharge, where G is gravity, acceleration due to gravity, that is 9.81 meter per second square. And H is the pressure head. So, if you want to control the flow rate, we have to control either pressure head or area of opening. So that can be accomplished with the help of pressure control valves. So normally the pressure control valves are pressure compensated or non-compensated pressure control valves. The flow rate of through the non-pressure compensated valves varies as the load or viscosity changes occurs frequently in hydraulic systems. For example, if the cylinder is used to move the bin, every time we cannot ensure that the bin is filled with completely filled or partially filled or unfilled. If the bin is fully filled, then the back pressure created by the fluid is more. So therefore, the pressure differences is very minimal. So the flow rate reduces. If the bin is empty, then the back pressure created by the system is very less. Therefore, the pressure difference will be more because the pump is pumping the fluid at very high pressure. So, since there is a very high pressure difference, the flow rate will be a very high. So, therefore, we cannot ensure that the flow rate is constant for all the times since the load is varying, it is constantly changing. Uh, on the other hand, viscosity also plays a vital role for deciding the flow rate of the fluid. Say, for example, initially we are starting the machine. All the machine parts are in atmospheric temperature. Therefore, the viscosity of the fluid will be more and the flow rate will be less. If imagine the machine is operated 8 hours or 12 hours continuously, the machine is heated up and the temperature affects the viscosity. So therefore, the viscosity of the fluid reduces. In that case, flow rate increases. So the machine operates very high speed. So these are all the possible problems in the uh, flow control valves since it is non pressure compensated. So therefore, we have to compensate the pressure to ensure constant flow rate. So the compensated valves are automatically adjusted the fluid pressure variations to produce consistent flow under varying load and temperature conditions. So the non-pressure compensated valves are maybe categorized into fixed flow rate, adjustable flow rate, orifice with a plate with hole or orifice is the example of a fixed flow rate. An adjustable flow rate, normal taps, what we are using in domestic applications. So these are all the examples of adjustable flow control valve. The simplest restrictor type flow control valve is the simple orifice. It is basically a calibrated hole. It serves as a non-pressure compensated fixed flow control valve for the hydraulic applications. So these are all the references for my presentation. Fluid Power, authored by Antonio Esposito, published by Pearson, New Delhi, the year 2003. The second reference, Fluid Mechanics and Hydraulic Machines, authored by R.K. Bansal, published by Lakshmi Publications, New Delhi, in the year 2021. So in this video, we have discussed about the introduction of flow control valve. I hope this video is useful for you. Thank you.